This meeting is being recorded.
Okay, let's start recording. And I'm still waiting this thing to pop up. Okay, so let's first just have a very short and probably non-comprehensive introduction to what's the idea of remarching is. So basically, to solve the rendering equation, because we want to join image, eventually we have to have some surface, and then we need to calculate some kind of resurface intersection. The dominant way of doing that is just doing some kind of rasterization pipeline and then use rasterizer to handle this job. The other way is doing ray tracing, and we calculate the analytic solution. For example, we have a sphere. The analytic solution is pretty easy to calculate it. We can easily, if we have a ray like this, we can easily calculate what this point is, or whether we have intersection at all. However, sometimes we want to express shapes like this, just some gross shape, and then there are no analytic solution to that. Of course, we can always triangularize the shape into little mesh, but sometimes we just have an implicit representation, which also have the one very desirable property of it's just infinite. We can, unlike mesh, has a fixed resolution. We need to do some kind of LD kind of stuff. But let's say we have just have this kind of implicit geometry, which is described by an equation. How do we calculate this thing, resurface intersection point? So when we don't have an analytic solution, of course we will do it numerically. So that's where remarching comes from. And the basic remarching idea is we march this ray like this. We go here and say it intersects or not. No. Go again. Intersect or not. Oh no. Go again. Okay, we cross the boundary, so we know we have intersection. So we choose this point, and we see its intersection point. It's not very precise, but at least we get somewhere close. Of course, doing this kind of marching is very slow, because we just have a fixed step every time, and for a long distance, we need to march for a long distance. So that's where this idea of sine distant field comes from. So sine distant field is the idea of, let's define a function to represent this surface. And at the surface level, it's 0. And everything inside the surface, it will be negative, whatever it is, we don't care. But at here, it will be positive, like 1, like 2. And this number will be less than or equal to the distance to the surface. And we just, if the number is closer to the distance, the better. If we march a ray, we can march at the distance. Let's say if we have this 1 is a very good number, it's exactly the distance to the surface when we march the ray. But then when we march the ray, of course, we probably don't have a ray at the exactly same direction. How can I change the color? So let's say we have marked the ray here. Maybe our rays go to this direction, to here, and this will probably get some smaller number like this. So we go again and again until again we just hit the surface with some probably with some epsilon tolerance, so like closer to 0 enough, then we just say we hit the surface and we're done. And this is much faster because we don't have a fixed step. Instead, if we have larger, like if we have two, we are tracing a larger sphere. Let's say we have another ray we want to trace. Because it's two, we can just go very far away and go this, and go this, go this, and then we kind of go far away, and we know we don't have intersection at all for this ray. Anyone good?
Sounds good to me.
Yeah, I don't know if I'm doing a good job explaining this because I haven't prepared for anything, but yeah.
Is the like the miss check, is that like how do you do that, like a certain number of steps or something? Because just getting increasing distance, I feel like there's some edge cases where that wouldn't cover it.
Yeah, you can fix them. Both have a max distance and have a fixed step cap. So yeah, both way works. Or you can just do both at the same time.
Makes sense.
Yeah, so now we have this remarching mob. We need a tag, demo, whatever, music description. Okay, so pretend I don't know anything about remarching. I don't know anything about this. So I'm just a typer, I will type stuff. And now it's your job to tell me how to do it and how to start writing this shader, basically.
Oh goodness. As someone who doesn't know how to write a sphere tracing or ray marching, this is going to be interesting.
Yeah.
I guess we have to come up with our some geometry first, maybe.
I feel like
probably want to start with the camera. Easiest way is start with this UV and get yourself -1 to 1 on X and Y.
Yeah, so a ray per pixel out into the world.
So it gets
right?
-1 to 1 at each direction.
Yeah, it's probably a good place to start.
Yeah.
Yeah, sure. So how to get from 0 to 1 to -1 to 1?
We have our 0 to 1. We just need to add for our UV to get. Are we going -1 to 1 for our X and Y, where Y is up and X is across and Z is in?
Sounds like a good standard.
Well, to transform the UV into that space, we just multiply by a half and then subtract a half. With the correct parentheses around frag chord and the resolution. Because that's going to multiply by 2, is it not?
Yeah, I multiply by 2 and subtract 1. Also work.
Yeah, that would work. I have a kitty assaulting me for petting, so half distracted. That's why the camera's not on. Oh, I should turn it on for.
Oh.
I'll try
Oh, we
to.
want to see your cat.
His name is Cheddar. So we have our UV. We need to generate a ray going into generate. We need to take that and make a ray out of it, and that pretty much just means putting it into a vec3, right? Oh,
Well,
I think it's
So-
into vec3. So what? And
orthographic camera is probably the easiest to start with.
yeah,
So we just use this UV as an offset in space, and then we just
Right.
use a consistent Z vector going forward.
yeah.
So you want to make a scale variable for X and Y. So it's a vec2 scale, and then you can multiply that by the NDC to create the orthographic camera. If that makes sense.
sorry.
I guess if you want the camera to be 2 units, 2 by 2, you make the scale be 1 in each dimension.
Yeah, I see what you are putting at.
Just an idea for coloring to visualize where we are on the screen there.
Something like that.
That was my thought. Now I'm second guessing it.
It seems
Vec3
reasonable.
calls for
So we have a vec2 coming out of the.
yeah, that's a good color to just see what we are getting.
Right. I feel like we need some sort of function that we evaluate against.
For array marching?
Yeah.
That's probably a good next step. So we just have a float return type and take a vec3
Yeah.
as an argument.
Yeah. So new function.
Then we load up JV's website and grab one of those functions.
Got plenty of things to look at once we get this working.
Oh, we can do a sphere first because everyone knows
yeah.
how to do sphere, right?
Yeah.
I think that's a good starting point.
Yeah. So we're
The function
So-
should take a position, right? If you want to return a distance.
yeah. Vec3.
Also, probably the origin and radius of the sphere, right?
Yeah.
And then
So what is the distance to a sphere with that origin and that radius?
And it's just the length function.
Yeah, I guess
Or
Um,
use the
just,
distance function.
like
Actually, don't know.
subtract your position from the origin, get that distance, and then subtract the radius.
Yes, because you got the 2 points. You figure out how far away they are, and whether you're inside it or not is if the radius is beyond that point or not on the line from your position. Should it?
Um,
Like,
oh,
Pause, comma, origin, not pause. If you could replace it with length too, if you want.
yeah. Yeah, I guess we can also do this.
Yeah.
Yeah, but we need to consider the positive or negative.
Right.
We
Oh, but I
can,
guess distance is always positive, so it doesn't matter.
yeah, we can let the caller worry about negative distances.
Yeah.
Not our problem, right?
Yeah, right.
Not yet.
So what's next?
Probably break
Yes.
out a separate function for the ray merging, just so we don't have it all in main. Just take the origin and direction as a as an argument. This would be 2 vec3s. What do we want to return from that? Probably a color, or
Oh,
maybe a number of steps. That could be an interesting thing to do.
yeah. For
We could do
starting.
any number of things.
Yeah.
We can do color for now. Yeah, we can have a like solid color for now, and then do some interesting stuff later.
Oh, yeah.
Yeah. I feel like a while loop or a for loop is in order for the marching. I don't know what the step parameters are. I doubt it'll be a normal fixed iteration count for loop. And we also probably
we can't have an iteration cap, but we need other conditions.
Right. So the condition, their one condition is you've exceeded the total number of iterations you ever want to do, like 10,000 or something. But the other one is, did we hit the thing? Did the distance ever go below 0, maybe?
Should we pass in the geometry to the function?
Feel like that's complicating it.
Maybe.
Just personal preference. I like having that globally accessible through a function like this sure SDF. But yeah, so maybe for some loop counter equals 0, and then break on it being greater than some maximum number of steps. Wanted to define that.
Yeah. It's a good start. So should we be calling the increment, or I guess that's based off of sphere SDF, how much we increment. So should there be a variable to store the amount we increment that step, and then we assign to it at some point?
Yeah, I think
Take a
we
look
should.
at it.
Isn't it just the distance?
The next distance should be.
Go ahead.
Oh, sorry. the next distance should be declared before the for loop.
The max distance.
No, the next
Oh yeah,
the distance we want to travel for the array. So it should start out at 0. So we evaluate the origin of the array immediately.
You mean like
So
the
I call it like next dist or something.
Next dist.
Is it the next distance or next position?
The next distance we want to.
right.
The distance we want to move the array in the next step of the traversal.
And we'll move it in the direction.
Well, direction should be constant.
Distance. Oh, yes. But I'm saying
Well,
we move it in that direction by the amount next dist.
Yeah, that makes sense.
We
Just
probably could
use some dummy stuff.
Yeah.
maybe it's a good idea to have a Sine SDF function, so we just do all the Sine when instead of doing this.
Mhm. Yeah, that's a good way to generalize it.
Yeah. Mm.
So we've got our first query of the distance there in that floating point number. So what do we want to do with that?
I guess first we should check if it, like, I don't know, do we need to check the origin? If it was like actually, probably not, because then you get this helper intersection, right? If we're doing any bounces, but
Well, so we want to get an initial step size.
yeah, so should we just go straight into iterating the, like, marching along the ray for by next distance, or should we check if that actually was a hit or not?
I was thinking we'd check if it was a hit after we evaluate. That way we don't have to have a special case for the first iteration.
Yeah, that's
Right,
better.
yeah.
If our next distance starts at 0, you know,
Yeah.
we don't want to immediately evaluate a hit.
So we
Like-
should have a special case.
I think
Probably avoid that.
So
Yeah.
like in the for loop, just do like, you know, the position to check is like origin plus the direction times distance. And then check if that's a hit or not.
I was thinking next distance equals Sine SDF and then move the
Yeah.
origin. Or I guess I wouldn't.
So we want to switch the order of those two, I think.
Yeah,
and then-
yeah, you're right.
And remove the part on the declaration. Just kind of leave it
Yeah.
uninitialized when we enter the loop.
Oh, to the infinity in
I can look it up.
We could just, a big number. 1E9 is probably sufficient.
Wait, why do we want to? Oh,
It
sorry,
doesn't.
yeah,
It doesn't really matter. We're setting it on the first thing there, so
yeah.
just whatever works.
Yeah. So we're going through the thing. We'll go through it like 50 times. What's the other exit condition? Is there another exit condition?
Well,
If
what
we-
we hit, we exit, right?
So
yeah,
how do we
you
know if
determine
we
that you
hit? Is that going to be like less than 0?
If
on the
next distance
distance?
is less than epsilon,
Yeah, you want to define
Yeah.
an epsilon.
Yeah. So first we define a very big number. Now we define a very small number.
Matching line lengths. That's good.
Break.
Cool. Or another thing you could add to that if condition is if you've traveled okay, so we're not retaining a So we're updating the origin, so we're not really able to support a max distance traveled this way. So we may want to have another vec3 that holds our current query position.
Query position? is
Where
that?
we're so like where we're calling the SDF function from.
Like
We
leave
may want
origin intact. And
right, exactly.
Oh.
Yep. Cool.
So what do we want to do with the origin now?
We can use it to calculate distance that the ray has traveled. Well, I guess we
Yeah.
could also just accumulate a float to get the t value.
that's maybe better because we don't have to do the like get the distance. We can just track the like we don't have to subtract the two vectors later. We can just track the exact distance.
Yeah, so have some accumulator initialize to 0 and then add next dist each time.
Yeah.
Yeah, that's the way I would do it.
I think we want to keep that last line as position, incrementing position there. The 19.
We deleted position.
Did we? Oh, sorry. Okay, gotcha.
So actually line 14 needs to be modified.
That's true, yeah.
So do we want to return T for now, but in a vec3? And then just draw that, see what we have. If it works at all.
Maybe should we in that if statement return a color and then outside the loop just return like black or something?
That's good. I like that.
Yeah, sounds good. So we've got origin. Okay, good. Next is
I should get,
okay. Yeah, awesome.
I think we'll get a white, we'll get complete white if we get it working.
I think the second argument to your scene SDF needs to be a vec3. Rather sphere SDF there, yeah.
Yeah. We don't call the function the shape, the ray trace ray march function.
Yeah, so we can update that initialization of color to be equal to our ray march function.
Yeah.
So what do we want to do for the? Okay, so we've got origin figured out. Cool.
That shouldn't work. Yeah.
Get red. Is it the sphere is really large? What if we change the sphere to be like 0.5?
Yeah, our sphere's position is.
We
Well, I
could
meant
just
the
mess with the radius.
Yeah. We made it like,
We can also do something like this.
oh yeah.
Note that we've also got an orthographic camera, so we're not going to see any depth.
Oh.
Oh yeah.
Making the radius
Yeah,
smaller.
but yeah, I guess it doesn't work.
Not only do we not have foreshortening, we also don't have correct scaling based off the width and height.
Yeah.
Yeah, that's right.
That's something need to be fixed. So how
We
to fix
normalize
that?
them. That's a good question. We basically need to figure out the aspect ratio and then multiply the UV by the aspect ratio. So that'd be iResolution.x divided by iResolution.y times UV. I don't know if that's good practice, but that feels like a way to do things.
Well, you only want to multiply.
Oh, and then we'll
You
have to,
definitely won't work.
You only want to multiply
Yeah.
the y component of UV.
Mhm.
yeah.
Maybe the other way around.
Yeah.
Looks pretty spherical.
Okay. So now our
What
UV
if-
coordinates. What? Sorry.
No, I was just gonna say, what if now when you return, when you break on your next distance less than epsilon in line 16 there, what if that 1.0 is divided by I, the number of steps you've taken?
Probably going to be a
Yeah, you want to cast it as a float, yeah.
pretty.
There's some cool effect.
Very.
So as you
it's,
take more steps,
Yeah.
yeah, you get darker.
I like the banding. So this is basically a primitive depth function. Can we make the green channel the t divided by
Nice.
I?
T is total distance.
Yeah, I was just trying to get it scaled so it wasn't massive. But now that I think about it, our Sine is so small, it doesn't matter.
I think we could probably use T directly, yeah. Maybe. It would clip, but yeah. Or maybe just some constant scale factor.
Yeah, that was just to see what it did, not really any direction we
Yeah,
had to
no,
go
that's
in.
totally cool. We're just screwing around.
So we have a sphere. Do we want to draw more things?
I think we're
other
done.
than
You can pack it up.
Yeah, right.
Maybe should we get the perspective projection?
Oh yeah.
Yeah, that might be fun. Anybody got any ideas on how to make a camera?
Some sort of trigonometry. Probably a
That's one
tangent.
Another way is to use the UV. So yeah, and this is
We
actually
have this origin, we can just use this as a direction, right?
Yeah, because right now we're just putting the rays forward. If we put the rays outward, wouldn't we get the perspective projection? Because the rays start marching in non-parallel directions.
Yeah, get the perspective from GLM.
And hopefully that functions more times than I can count.
But we don't do any. We are doing this kind of ray marching ray stuff, so the perspective should be really easy compared to in GLM when we need to calculate the perspective matrix.
Mm-hmm. So we're looking down the negative z direction. So so we're gonna want to offset the UV a little bit if we want to do it this way, because if you say origin equals vector UV and like 1, and then we normalize that, that's a way to kind of get the directions. Okay, so you there you go, yeah. Then we'll want to do want to do the origin separately. So they may be looking in the wrong direction. Yeah, we may want to flip something around.
Hey.
Hey.
Okay, so we take our UV, which is the square, and then we normalize it with -1. Is that just to invert it? Yeah, that's to invert it.
Well,
So, yeah.
It's not inverted. We just put this plane a little bit
Right.
far away from the camera.
Oh yeah, because we're going from. Okay, so
Yeah,
each.
exactly.
Okay, yeah, it's like a little TV with the electron gun.
Exactly.
Except it's this way because we put it negative in the z-axis. I like my electron gun analogy.
I do too. I think that's a good way to think about it.
Pretty accurate.
And then we march in that direction, going off in those directions. Do we want to add more stuff now? Because or do we want to make the marching return different things, colors and stuff? Like, do we want to make it more spheres or a sphere that's prettier?
Maybe prettier, so it actually looks like a sphere.
Yeah, we can do normal and font shading. For normal, we can probably just copy paste from somewhere. No.
Yeah, that's
How-
gonna
we
be.
We
could
can
probably
compute
just
a
do-
normal pretty easily, or we can figure that one out, I think.
Yeah.
Okay.
The
Hopefully
normal
we
is
can do it.
looking at the gradient of the distance function.
Yeah,
So
so
we're
it's gonna take
looking at-
3 extra samples of neighboring SDF.
Yeah.
Wait, why 3?
So you got to get the rate of change on the X,
Oh.
Y, and Z.
Yeah, so you take 3 extra samples. You take 1 sample with a small X offset from the hit, and then another sample with a small Y offset, and then
I was
another
just
sample
picturing
small V
4 by
offset.
taking
Yeah,
a
and you-
previous X offset as well.
Yeah, and you get the differentials for each one.
I was thinking like you put it in a triangle around it, and I was very confused because you'd have to be like a little bit in the X and a little bit in the Y, and that just is not gonna happen. Easily.
I've seen it done. I've seen it done about 4 different ways, and one of them is a tetrahedron. They use tetrahedral arrangement of points around the point.
If it works. So should we make a new function for getting the normal? Definitely. Yeah, and we basically we sample it at 3 different points, so we need an X, Y, and Z vector to store the SDF that is sampling the sphere SDF or Sine SDF at, pose plus a very small X number. Vec. Yeah. Probably should make that global. Well, we need to surround the epsilon with a vec, and it'd be. Or wait, how do we get X?
Also, we need to pay attention to the return type on Sine SDF. That's not it's not a vec 3.
Oh yeah, it's oh. Yes.
Right. This is what you want to do.
You could probably do an analytical normal, like for this, if it's just a sphere.
What if we
Yeah,
want
it's just a
March
sphere,
12th?
but why? Yeah, we know it's just a sphere, but why we are doing remarching if it's just a sphere, we want to do remarking because we want to do it on weird shapes, right?
Yeah, we
that's
wanted to
true. If you want to
Get
make
to
it
the weird
general,
shapes later.
if you want to do
Yeah.
general,
The sphere is just a demonstration.
So now we have those the distances on the different axes.
We need to
Now-
compare it with the distance from the original sample. So I think the function needs to take another argument for the original distance.
Yeah.
Or we could just take a fourth sample, but it'd be unnecessary, right?
Yeah, and we basically, oh, no, I don't know. I'm thinking of just subtracting the two, x minus dist, comma, y minus dist, comma, z dot minus dist, and that's our vector, but I don't think that's right.
You have to divide it by epsilon, right? So like this
Yeah,
classic, like the limit definition of a derivative. It's like
that,
yeah, I think you evaluate the 2 points, subtract them, then divide by the distance between the sample
Yeah.
points. I think
that feels,
it's like
Right.
the limit of h as h approaches 0 of
right? You
f
still
of
have to
x.
subtract. You have to subtract the non-epsilon added one, right? You still have to do
Right,
like
yeah, you need that
you
distance.
need dx, dy, dz, not just x, y, z. So
Yeah.
dx is equal to x minus sin s df at the position.
yeah. Then we just, or we can return vec3 of dx comma dy comma dz divided by epsilon.
May want to just normalize it.
Oh, that would actually be much easier. Vec3. Okay, got our normal. I just return the normal of the point and see what it shows us. Origin. Next dist, right? Yeah.
Hey, there's something. Looks right.
Looks like a UV. Just
By
straight-
multiplying.
Our normal is
That's
our
kinda
normal
weird.
is from like -1 to 1 range, right? So
Yeah,
we
multiply by a half.
adjust it.
And subtract a half or add a half.
Yeah.
Also, we never divided by epsilon, right?
No, wait, we normalized.
Yeah, normalize kind of circumvents that a little bit.
Shouldn't we divide by epsilon then normalize?
I don't think we need to do anything with epsilon. Theoretically, the epsilon should be 0, or it should be as close to 0 as possible.
0 in quotes, yeah.
But it's not,
Yeah.
right?
The
Well,
calculus
we
Yeah,
have
it
to
definition
can't
is
be
go-
too
0.
small because of floating point precision stuff.
Yeah. We'd have catastrophic cancellation. But like with the dx, dy, dz vector, we have a point, a direction is just very small, and normalizing just extends it to the unit circle, unit sphere. What's a fourth dimensional sphere called?
Hypersphere.
That's lame.
Well, that's just a generic term for a sphere,
Yeah.
I think.
Yeah. I guess there really isn't no names for those things. I just was curious. Yay, we have a normal. Now do we want to do some sort of lighting with that normal?
What if we added another couple spheres just to, so we had something to look at?
Sure.
Maybe
Yeah.
we could make the sphere reflective. Have it reflect the other sphere. Maybe I don't know. Not sure how we want to do this. I might
So you
just
want two spheres?
Could
Yeah.
we subtract a sphere from one other sphere? So
absolutely.
like the not intersect but difference the two. Do we just we don't just subtract the sphere function from another sphere function, or do we? No.
I think you do.
That's just distance.
Isn't it like a min or something?
Min is combination.
Oh, right. Okay. Yeah, which one is it? Let's see.
Well, why don't we just
Or
add
maybe
multiple
back-
spheres first, so, instead of trying to tackle differencing them.
Agreed. So
Cool,
you just
yeah.
add the distance. Oh, wait.
No, we need to take the min of the two. Yeah.
Yeah.
Where do we want this other sphere to be?
Maybe up a little bit. Something.
It should be further back too. Oh,
Yeah. Very nice.
yay. Works for me.
Are you sure the normal is correct?
Yeah, I think we might
No.
have something a little funky there.
Oh, I
do
see
not.
green on top. That's a good sign.
It is, but
Wait, I also see green on the left
yeah.
side of the right sphere.
But the front, the part that's closest to the camera, is different between them. Right?
Do we have a perspective camera right now?
Yes, we do.
Yes.
I don't know if perspective accounts for that much of a difference, but
So it looks wrong.
Well,
yeah.
there's red on the left one, and there's red on the rim of the right one, and that feels wrong.
It does kind of.
I got I kind of want to just ignore it, but because I don't know why it's doing that. Why would it be wrong?
Yeah, I honestly don't know about this because I usually just copy the normal calculation somewhere.
Yeah, that's the usual.
Maybe we do want to
have
divide by epsilon after all.
Do we
Someone
have
was
to?
saying something.
No, we do normalize, so divide by something doesn't matter at all.
It's still going to be
Sinus
unit line.
df is a distance, right? It's not the actual XYZ. So maybe we need to convert it to, we have to. Do we need to actually remarch each of those or no?
Definitely see we don't need
Oh.
that.
Is it definitely wrong?
Not definitely. Might be wrong.
Yeah.
Yeah.
Yeah, maybe someone can check the normal.
I
I'm
did just
actually-
look at Inigo Quiles website, and his surface
Yeah, let's check
normal
this
calculation
link
seems the
because
same.
this link has a normal code. At least as I remember, because I haven't checked this for a long time.
I have handy.
Yeah, this is how I learned this stuff basically. There's a normal.
We've got 3 different
Yeah, like
methods. In
your method 2 you have there, JB. I think that's basically what we're doing, right?
yeah, there's
This,
a couple
and
different
this.
patterns to take those samples.
Yeah, that's basically what we are doing.
Mhm.
So let's just assume it's correct.
Yeah, it seems reasonable.
If we make the position, well, is
Oh, yeah, it's
iTime
correct.
is iTime a global? It is, right?
Mhm.
The
Okay, I was just
uniform.
saying, could we multiply the position of the spheres by iTime, the sine of iTime? Would be at the top.
If you
Or,
Google
yeah.
sphere normal map, it looks the exact same.
Yeah.
And keep in mind that the normals that we're seeing are warped because we're multiplying by half and adding a half.
And
Wait.
also the fact that we've got
That's
the ray
not-
divergence.
Okay, I meant the not position, but the vector next to it, which is the actual position.
Oops.
Oh, right.
I guess it's yes.
Moving the camera.
Still very weird. Wow.
Right. I'm just trying to figure out if the normal is coherent across a range. Maybe we just want to do an individual axis like y. Yeah.
Why is 0? Well, we can do that.
Yeah.
Maybe scale it by 0.1 or something. Keep it a little bit more reasonable.
Yeah.
That's just going to be slower.
Well, that's fine. We just want it to move
That works
slowly.
too.
It moves really slowly.
So slow.
Yeah, it looks reasonable.
I
Weird,
think they
though.
are correct.
Yeah.
We're just seeing
let's-
different parts of the sphere, like more drastic
guess we
than we
are.
thought. For
We
an
have a
orthographic,
pretty crazy FOV, I think, based on the camera that we set up.
Yeah, I think
Yeah.
our spheres are deceiving us because they have a perfectly spherical shape. The perspective
Yep.
change is not visible.
if we switch to orthocam, they should definitely look the same though.
I think
Oh,
that's
how-
probably a good way to validate it.
Yeah. If we
If you just Google sphere normal map, it looks the exact same as what we have.
okay. So do we want to do the orthographic camera or do we want to just try to make the spheres look prettier, like lighting or something? Simple cosine fall off from a point light?
Could add a light, even directional light
Yeah, even a direction.
or point light.
What if we put a point light in between them, like at a constant height?
Yeah, that'd be cool.
Yeah. Yeah. That's also a good change.
Yeah, I agree.
Or put a point light between them. How to do that?
Main image is where we do the shading, I think. So after we march and get the normals and all the geometry information, we can shade.
Really.
Yeah, there you go.
Oh, we'll need the position
Yeah.
too, right?
Yeah.
Position.
Well, we need the origin as well.
Here's
Yeah,
just
so this should return a struct, right?
that's one way, or we could just make our normal function do the distance for the point itself, and that kind of simplifies that a little bit because then we don't need to know the point's distance. We could just we can the second argument can be replaced by a distance function query inside the thing. Yeah, exactly. Yep.
Yeah, we can extract normal out if we do this.
Should be the same. Okay. Yeah, there you go. Cool.
Well, and then so should we return the position instead? From array marching, like return the position, and then we can calculate the normal outside the array march.
So we'll
Is that
just
what you're
return
saying?
origin.
Yeah.
Yeah. Then
Yeah, but we still have one problem whether we hit something or not?
Does GLSL have optional yet?
Of course not. It's GISL. So return struct.
Could do.
I mean, that would be better.
Can you do like a references in GLSL, like in out values?
Oh,
Yep.
Yeah, you can. You can.
There's in and out keywords.
Okay, so I mean,
Yeah,
it's kind of
things
gross,
like
but we
that.
could do that. And then just return a Boolean from the function, but that's not the nicest.
It works.
could we also do a I'm just thinking we should also, if we're gonna do that, we should also do, oh yeah, out of origin there.
But you
And
know what I
then-
think would be better? Returning a struct.
Oh, so would we just have like a field, a flag in the struct of like hit or not?
Well, if the T is negative, we know. Well, I guess if the array spawns inside of geometry, so yeah, we might need a flag.
Do we need to update origin before we return true?
Yes, we do. Well, do we? Yes, probably.
Because
Probably move that before the if condition.
Doesn't matter because it will be very small, right?
Wait, do we want to do that?
It will
Yeah,
be a very
shouldn't
small
matter.
change.
I don't think we want
Shouldn't
that.
matter. So if we have that, maybe call it origin, even though it's actually a position.
no. If hit. Yeah. We can do vec3 normal. Oh yeah, we can just,
No,
and then origin pull, then yeah, times 0.5 plus 0.5. Then that should get us back to where we were. It looks the same.
Very nice. So now we've got both position and normal direction.
Yeah. So we should do a point light or something in the middle of the sphere, in between the spheres, in the middle of the scene. So that would be, do you want to do quadratic fall off? Should linear fall off? Intensity of the light would be the distance between the position of the light and the position of the hit. And then we could do
Inversely
it,
proportional.
right, inversely proportional. So, well, I'm just thinking we yeah, and or we need to get the distance between the position of the light and the position of the position that we hit, and then we can get do the inverse square proportional thing. Right.
Sounds good.
Yeah. So is that distance between those 2 points?
Yeah, that's the correct distance.
Yeah. So float. Distance. Yeah. And then origin. Then we multiply. What if we just for now multiply col by 1 over the, getting fancy here. Shoot, no, that's not, okay. I'm trying to think of the fancy way to square, oh, dot. Do dot of light distance.
The float, you can't dot a float.
What? Oh yeah, you can't, but you can if you do dot light distance, comma light distance. Wait, no, you can't. Okay. I'm being too
multiply
smart
it.
for my own good.
Just multiply it by itself.
Yeah. Okay.
Also, if you want to know that, well, the one-dimensional magnitude is just absolute value.
Why is
Light
it
is
still?
too dark.
We've got to consider that we're looking at vec 0 here, and our spheres are bumped along the z.
And we're not taking into account the normal.
Right. We're not. That would be that would just be additional fall off.
If you scroll up to your main scene distance function, look at where the spheres are. We've got a -2 on the z-axis.
So they're actually kind of far.
Oh,
So can you just
yeah, we
increase
can
the,
change that.
Well, maybe we would want to change it on 46. Yeah.
There.
Hey.
there you go.
Okay. So that's why it looks so nicely uniform. The light was pretty far away. And it's maxing out. Great. Now do we want to do the cosine fall off where we take the normal and the, okay, I'm blanking.
So it's the vector from the hit position to the light.
Yeah, we dot the light, the direction to the light and the normal of the surface. And then we yeah. That's just going to be the hit, or the origin minus the light position.
Mhm.
And then
I didn't follow what you were doing. And I don't know why you did those things. I'm going to be honest.
okay, sorry. Yeah, I guess it's unnecessary to change this line. I just changed it.
Okay, that's fine. It's just like, yeah.
It is doing the same thing basically.
Yeah. So now we just need to multiply col by, yeah, the dot product of light dir and normal.
Oh, but we want to get rid of the. Oh, okay, yeah.
Yeah.
I'm gonna change inline 50 too.
Well, we're not.
The
Oh, I guess
name of the function.
We should normalize the light there, right?
Yeah,
Yeah, it should be normalized.
that would be very good.
Also, you should take the max of the dot product and 0 at the end, so you don't have negative light attenuation.
Or we could leave it and see what
Yeah.
happens.
That's
Oh, you need to-
completely wrong.
The light
Something
vector is
backwards.
backwards.
Yeah.
Oh yeah. Yeah, it is negative attenuation. Spoopy.
Okay, we have Lambertian shading.
Look at there.
Yeah,
With our color source being the normal on a sphere.
yeah. Yeah, but well, if we want to change, we can just change this to a pure
Right,
color.
right.
It doesn't matter, yeah.
Yeah. It's a good
Do you
start.
want to stop here? We can
I
like
think so.
yeah, continue doing this in
Another
the
time.
future.
You
Yeah,
want to drop in a different distance function and see what happens?
Sure.
Oh, yeah, throw away your distance functions.
yeah. Someone has a good distance function they want to show.
Let me find one real quick.
JB has a bunch.
Yeah, I got a pile.
Yeah.
Let's see. Let's do it.
So next week we're adding a PBR, right?
We could do some lighting next week if people are interested. Could do a little bit of prep work for that. Let's try this one. Just need to change the name of the function, but the rest should be pretty similar.
Is that right?
Well,
What?
Do we want to turn the lighting off?
Yeah, that
Oh, yeah,
is
we have one
correct.
light. It's tiny.
Yeah, that might be a little too complicated for this. The shape is a little too complicated. Let me find a better one.
Just do the normal base shading we had before. I think it would be
That's probably safest.
readable enough.
That is probably safer than messing around with this. Ooh. Could do that, or we could try this one.
A new one?
Oh, either way is fine. Yeah.
Is that how it's
But yeah,
supposed to
so
look?
that is how it's supposed to look.
that's pretty
Oh,
cool.
it's not like-
Eyes undefined. Okay.
I can link the image I have of it. 1 second.
3. Pi is equal to 3. It's way more precision that's necessary.
engineer's definition.
Yeah.
Oh wow.
When you
Oh.
realize,
That's pretty cool.
oh, and
That
it has
one's a
our spheres in
gyroid.
it too. Yeah. I really like this debug, using the normal as the.
Ooh.
Oh, can you
Looks
decrease
cool.
epsilon for the normal function? It's just giving us some sort of outline on
Yeah,
edges.
I like that line.
but yeah, but I know if it's like when you
Good precision issues there.
we get precision issues because
Oh, actually, yeah, it shouldn't
like,
matter.
yeah, a float is pretty limited for this. Like this is like, just not working.
Neat. Yeah, we could do shadow occlusion and maybe some lighting next week.
Yeah,
Fancy
yeah.
If people
lighting.
are interested.
Yeah, do you want to do this next week?
Yeah,
Sure.
Sure.
this is fun.
Yeah.
I can try and get something together as a starting point, so that we've got something to work from if you want. Or
Yeah, sure. I will like put this online later. Put this shader. Just put it public. I will stop recording.